And welcome back. As we continue to look at derived classes and inheritance, today we're going to take a look at how we want to look at base methods and how we can actually redefine them for use in our derived classes. So here's a quick tip to kind of start off. Remember that static methods are inherited. So we kind of already identified that static variables in base class can be inherited by any derived class. Well, the modifiers public, private, protected, and package access, which we have now fully explored, have the same meaning for our static variables as they do for our regular instance variables. Now, that, of course, is going to lead us to how do we access this to a redefined method? How do we actually put these things into play? So let's first say we want to redefine a method so that it has a different definition in our derived class from what it has in the base class. Well, the definition that's given the base class is not completely lost to the definition of the derived class object. However, if you want to invoke the version of the method given in the base class with an object of the derived class, you need some way to say, hey, use the definition of this method in the base class. This is the way you would say that the keyword is super, as if it were calling object. So we're going to see super used again here, and it's going to kind of be our friend to making our life a little bit simpler. So let's actually look at this with some examples here. Let's actually kind of pull this apart and figure out what does this actually mean. Well, let's look at the toString method of our class hourly employee, and this is how it's currently defined. We have a public string toString. We're returning getName plus getHiredate.toString plus a new line there for a $, wage rate per hour for the number of hours. Pretty self-explanatory. This, of course, is overriding the definition of toString that was in the base class employee, which simply just gave us the name and the hire date toString. Now, we can, of course, redefine using the super keyword, as I've already talked about. And let's see how that actually starts coming to play here. And if we want to simplify that definition of toString in hourly employee, because you'll notice right now there's like 4 things we have to print out. We can actually use super to help us simplify that so we don't have to have this big, long, giant toString. So here's another way to write toString in hourly employee. You'll see it's exactly the same as what we had before, except we don't have the getName that was in there before or the getHiredate. Instead, now we have a super.toString that is here. And this super.toString is replacing that chunk of code that we had before. So when we look at redefining and derived classes, that expression super.toString is actually invocation of the method toString that exists within employee. So it's saying, hey, use the super definition, the one that's in the super class for employee, and not the one that is existing here within the derived class. Now, we can only use super in this way within the definition of a method in a derived class. We can't do this to a base class, obviously, because if we're in the base class, we can't super call anything. Outside the definition of a derived class, you cannot invoke an overridden method of the base class using an object of the derived class. This would be another thing of it as invoking an overridden method. Now, one pitfall to kind of be aware of is that we cannot use multiple supers. All right, you can't do like a super.super, as we're going to look at right here. Because the definition of a method of a derived class, when we call an overridden method of the professing name, the super, we can't repeat the use of super to invoke a method from some ancestor class other than a direct parent. So it can only be the one that's like immediately above it. You can't do a super.super. So let's just say we had, for example, full-time employee, which is a derived class of hourly employee. Well, full-time employee, if it were to do a super call of the toString method, would only look at hourly employee. You would have no way for it to super call that of employee. So let's just say we have the class employee was derived from the class person in this example. So another way to look at this, and then hourly employee is of course derived from employee. And if we were trying to invoke a method class person within that definition by using super.super, for example, super.super.toString, this would be illegal. We would not be able to use this within our code without it throwing an error. You cannot have multiple super invocations in Java. So there is ways to kind of still get some of the information, but you can't have the super.super invocation. You might think, well, if I just have a super for hourly employee to get employee, then I could do say like a super.super to get to person. No, it doesn't work like that because again, it's only for that direct parent class. And so let's just go ahead and take a quick look at how that would work here in code. So this, of course, is my toString method that we had talked about before. And so here we have getName and we have getHireDate.toString. And what I want to do is replace this with a super call, because this is effectively the same code that exists here in employee, right? Because we have name and we have HireDate.toString, and we're just changing those to getName and getHireDate.toString. So if I replace these here with a super.toString, so I'm just going to go ahead and just do super, you'll see it automatically takes that there. And now we have super.toString is equal to all of this, because these will output to the same exact thing. The only difference is it saves me from having to type out a bunch of code. And what it does, it uses those properties of inheritance to say, oh, you want to use the same toString methods that exist here. Now it's still going to print out these pieces here. It'll still do the name and hire date. It's not going to not print them. It's using the super call to do that instead of us having to put in get name, get hire date, etc. We could do the same thing with, for example, with equals here. So you can see here we have a get name, we have a get hire date, and of course we have wage rate and all that stuff. So we would have to, in this case, test these out with the appropriate object. Now the one thing we might run into here is you can see here when we do our equals, it says other.getName and other.hireDate. So it can be a little trickier when we try using something like this, because here you have to have it equal to something else. So if I do a super call and say dot equals, you have to be careful that you make sure you have the correct object in here. So here we're looking at the other here, all right? So you have to make sure you pass in that object here. Now Eclipse is very nice to help me with that, but sometimes you still might have to think, is this the correct thing that we're passing in here? And again, this is going to work exactly the same as how we did our toString. If we look here in our employee object, it's saying, look at this information here for the name and the hire date, test that for equality, and then also then test our other parameters here as well. Both of these still work, and if you're like, well, this is a little bit too much for me to try to remember, you can, of course, leave this for both of these in what we had previously. Both of those are acceptable, but again, you can use super to just kind of condense your code a little bit here. And again, both of these are going to work exactly the same. The only difference is that this is using our properties of inheritance to go ahead and pull those other pieces of information.